Here the topic is the network design issues. Now what are the design issues related to the network layer? The first one is the store and forward packet switching. Second one is the services provided to transport layer. Implementation of connectionless services, implementation of connection oriented services, and the comparison of virtual circuit and datagram network. Now what is store and forward packet switching? This is the host one where the process P1 is running. This is host 2 and P2 is running. Host 1 transfers the packet to the host 2. It follows the path A or B, D, E, F or A, C, E, F. The route is A, C, E, F in this case, where it is connected to the LAN. Host 1 and host 2 are. This is the ISP equipment. This is the router connecting. Next one is the services provided to the transport layer. Services independent of router technology. Transport layer shielded from number, type, topology of router. Network addresses available to transport layer use. Uniform numbering plan even across LANs and WANs. Now implementation of the connection and services. This provides the implementation with routing within a datagram network. This is the implementation of the connection oriented services. Each of the hosts are connected to the network. And these are the comparison of virtual circuit and datagram network. Here the issues are circuit setup in the datagram, it is not needed, whereas in VCN it is required. Addressing each in datagram, each packet contains the full source and destination address, whereas in VCN each packet contains a short VC number. State information. The next issue is state information. In datagram, router do not hold state information about connections. In VCN, each VC require router table space per connection. The next one is routing. Each packet is routed independently in the datagram, whereas in VCN, route chosen when VC is set up, all packets follow is. Effects of router failure. None except for packet lost during the crash in datagram. All virtual circuits that pass through the field router are terminated. The next issue is of quality of services. Datagram network. It is difficult. It is easy if enough resources can be allocated in advance for each virtual circuit. The next is congestion control. It is difficult in datagram network, whereas it is easy if enough resources can be allocated in advance for each virtual circuit. These are the routing algorithms which we already discussed in our previous video. Some of them are optimality principle, shortest path algorithm, flooding, distance vector, link state routing, routing in ad hoc network. There is broadcast routing, multicast routing, anycast routing, routing from mobile host, routing in ad hoc network. What is fairness versus efficiency? Network with a conflict between fairness and efficiency. Fairness is when all host and the client are communicating easily, whereas efficiency is the throughput of the network. Next is the optimality principle. Shortest path we have already discussed. Link state routing. It includes the following steps: discover neighbor, learn network addresses, set distance codes metric to each neighbor. Third is construct packet telling all learned, send packet to receive packet from the other router, compute shortest path to every other router. Learn about the neighbor, a graph model. Next is the Anycast routing. Anycast routes to group 1 topology seen by the routing protocol. This is the routing from mobile host, the sender and the homogeneous home address, register address of register care of address, send to home address, tunnel to take care of addresses, reply to sender, tunnel to take care of addresses. Next is the routing networks. Range of ACE broadcast after B and D receive it, after C and F and G receive it, after EH and I receive it. Here the shaded nodes are new recipient, the dashed lines show possible reverse routes, the solid line shows the discovered route. The different congestion control algorithms are approaches to congestion control, traffic aware routing, admission control, traffic routing, load shedding. Congestion control algorithm. When too much traffic is offered, congestion sets in and performance degrades sharply. What are the approaches to congestion control? Network provisioning, traffic aware routing, admission control, traffic throttling, load shedding. This is the traffic aware routing. A network in which the east and west part are connected by two links. This is the link. Network throttling. It is in a congestion network. The portion of the network that is not congested. This is not congested. These are the congestion. A virtual circuit from A to B is shown here. This is traffic throttling. Explicit congestion notification. When the congestion occurs, the notification notifies the sender. Load shedding. A choke packet that affects only the source. A choke packet that affects each hop it passes through. Next is the quality of services. It includes application requirement, traffic shaping, packet scheduling, admission control, integrated services, and differentiated services. These are the application requirements based on the email, file sharing, web access, remote login, audio on demand, video on demand, telephony, video conferencing. Categories of quality of service: constant bitrate, telephony, real-time variable bitrate, non-real-time variable bitrate, available bitrate. This is the traffic shaping packet, a leaky bucket, a token bucket. Packet scheduling. Kind of resources can potentially be reserved for different flows. Bandwidth, buffer space, CPU cycle. Okay. Next is the internet networking. How network differs. How network can be connected, tunneling, internet routing, and packet fragmentation. How network differs. It is on the service offered. The some possibilities are connectionless versus connection oriented, addressing different sites, flat or hierarchical, broadcasting, present or absent, packet size. Each network has its own maximum, ordering, ordered and unordered delivery, quality of services, present or absent, many different kinds, reliability, different level of loss, security, privacy rules, encryption, parameters, different timeouts, flow specification, etc. Accounting by connect time packet, byte or not at all. Some of the many ways network can differ. How network can be connected is shown here. This is tunneling. Next is the packet fragmentation issues. It is based on the hardware, operating system, net protocols, compliance with national standard, reduce error-induced retransmission, prevent packet occupying channel too long. The network layer principles: make sure it works, keep it simple, make clear choices, exploit modularity, exploit heterogeneity. So these are the design issues in the network layer protocols. Thank you.